This video contains the solutions to take-home problems number 23. These first couple of problems are all about rules of exponents. So the rule that we're talking about here is that whenever we have x to the a divided by x to the b, the result is x to the a minus b. So on the top we have x squared, and on the bottom we have x, which we can think of as x to the first, and so that means that we have x to the 2 minus 1, which is just x to the first. And then we have y cubed divided by y to the fourth, so that gives us y to the 3 minus 4, which is y to the negative 1. So we could write our answer as x times y to the negative 1, except that we have to write our answer so that all exponents are positive. So there we have to remember the rule for negative exponents, which is y to the minus n means 1 over y to the n. So instead of xy to the minus 1, we write that as x times 1 over y, or in other words, as x divided by y. Same idea here, obviously a little bit more complicated. We have 3 letters, x, y, and z, and we also have coefficients. We have a 3 on the top and 9 squared on the bottom. So if we could think of 3 as 3 to the first, then we have 3 to the first on top, and 9 is 3 squared, so that's 3 squared squared on the bottom. We have x to the minus 3. Now, whenever we have a product raised to a power, we can raise each of those individual terms to that power. So we have y to the minus 1 and z squared to the minus 1. Similarly, on the bottom, we have x cubed and y to the minus 1 cubed, and then z squared. So let's simplify those powers raised to powers. Remember that whenever we have x to the a, and then that's raised to the b, we multiply the powers together, x to the a times b. So we have 3 to the first on top, x to the minus 3, y to the minus 1, z squared to the minus 1, that's z to the minus 2. On the bottom, 3 squared squared, that's 3 to the fourth, x cubed, y to the minus 1 to the third is y to the minus 3, and then z squared. Now we're going to subtract our exponents. So we're going to take 1 minus 4, minus 3 minus 3, minus 1 minus minus 3, and minus 2 minus 2. That's going to give us 3 to the minus 3. Minus 3 minus 3 is minus 6. Minus 1 minus minus 3 is positive 2. Minus 2 minus 2 is minus 4. So anything that has a negative exponent, that's going to get in the denominator. So we have y squared on top, 3 cubed on the bottom, x to the sixth on the bottom, and z to the fourth on the bottom. And that's our simplified expression. Our first technique for solving exponential equations is to look for when we can make the two sides of the equation have the same base. In this case, we have 3 to the 4x plus minus 1, and 9 is 3 squared, and that means that these two exponents, 4x minus 1 and 2, have to be equal to each other. So 4x minus 1 must equal 2, so we add 1 to both sides, divide both sides by 4, and we get that x equals 3/4. For an equation like this, the exponential term, this is the exponential part, is not by itself. And the trick of making the bases be equal only works if we only have a single exponential term all by itself, which means the first thing we need to do is get rid of all this extra stuff on the left-hand side. So we're going to start by subtracting 7 from both sides, and then dividing both sides by 5. And now, if we rewrite 4 as 2 squared, we see that these two exponents, x and 2, must be equal to each other. So x has to equal 2. Finally, we have this equation where we have a 4 as the base on the left and an 8 as the base on the bottom. Now, we can't easily write 8 as a power of 4 or 4 as a power of 8, but what we can do is write both of those as powers of 2. 4 is 2 squared, 8 is 2 cubed. So multiplying our exponents, we get 2 to the 2x equals 2 to the 6x minus 10. That means that these two exponents have to be equal. So we set 2x equal to 6x minus 10. We'll subtract 2x from both sides, add 10 to both sides, we get 4x equals 10, x equals 10 divided by 4, which simplifies to 5/2.